Okay, let's now discuss about the return type of the virtual function. Under normal circumstances, the return type of a virtual function and its override must match. Okay, as we told, signature must be remain same in base class and its derived class. Okay, just look at this example. Here, base is act as a base class and derived act as a child class, and derived class is publicly inherited from base class. Now look at the base class. Base class has one function called getValue and function declared as constant, and its return type is int, and this function also a virtual function. So to support what? To support function overriding. To support function overriding, we need to follow the same signature in the derived class also. Now look at the derived class. Derived class uses the same name of the function, fine. Function also declared as constant, fine. List of argument is none in base, as well as list of argument in derived is also nothing. But return type in base is int and return type in derived is double. So it is not function overriding. Here we are going to consider get value of base is different from get value of derived. Okay, so you should keep in mind return type also need to be same. Next point regarding virtual function, it is also a suggestion that do not call virtual function from constructor or destructor. Why? Let's try to understand with simple examples or simple diagram. Suppose we are inheriting a class called B from A. We are inheriting a class B from A. So here B is what? B is derived class and A is base class. Now think that inside the class A's constructor, we are calling a virtual function. We are calling a virtual function of class B. Okay, so we are calling a virtual function of class B. Now we should keep this point in our mind that before when you creating the object of class B, before creating the object of class B, class S constructor will be created. That means after creation of the class S object, class B's object will be created as part of the B's object. Okay, so A will be first created, then B will be created. Now what we are doing, we try to call a virtual function of B from S constructor. So it leads to a problem here. Then what will happen? Then S virtual function get called. So it tells us that remember that when derived class is created, base portion is constructed first. So we cannot call a derived class virtual function from a base class constructor. Okay. So if we were to call this, then what will happen? Then the base version get called before the creation of the derived class from the base constructor. Okay. Similarly, we cannot call a virtual function from destructor. Okay, similarly, we cannot call a virtual function from destructor also. Suppose that A and B are sharing a relationship, easy relationship. Then what we want to do, we try to call a virtual function of B from S destructor. From S destructor. Then what will happen? We know that B is a child class and A is a parent class. And we also know that before calling the destructor of parent class, destructor of the child class will get called. So if destructor of B is called first, then all the virtual class written inside B will not available to calling from the S destructor. So this is the reason that we always suggest that do not call any virtual function neither from base class constructor, neither from base class destructor. Let's go in deep about the virtual function. There are a few downside also of the virtual function. What is the downside of virtual function? Here is the question. Why not just make all function virtual? Is it okay if I declare all the function in the base class as virtual? Look at the answer. Answer is that resolving a virtual function call takes longer than resolving a regular one. The reason is that when you declare a function as virtual in the base class, then while you calling a function, it's implement the late binding here. Means function call get resolved here at runtime, and we're going to use a base class pointer to resolve that. So it takes too much time rather than we can call a function directly using derived class object. So one most important suggestion for all the new programmer is that whenever is possible, ignore virtual function, and if it is most necessary, then declare a function inside the base class as virtual. So this is the one most downside of virtual function. Further, the compiler also has to allocate an extra pointer sorry, extra pointer for each class object that has one or more virtual function. To resolve a function call, if you go back to our previous examples, yeah, this here how many class we have? We have three class: class base, class derived one, and class derived two. So for each and every class, compiler will allocate one pointer because this class has one virtual function. So if a class has at least one or more virtual function, then a compiler is going to use a pointer to resolve the function call. So this is the reason we always suggest to the new programmer is that whenever is possible to declare a function as virtual, because it takes time due to these steps. Okay, so I hope you understand the virtual function, and I encourage you should practice the problem that we have discussed in the previous lecture, animal, cat and dog problem, and try to implement virtual function inside the animal class and then check can we call the speak method of cat or dog using animal class pointer and reference or not. If you have any further query, you should post your queries again this lecture. Thank you.